Basically, you'll have to do what Cylake is doing, which is to rebuild the entire cybersecurity stack on top of your custom data pipeline and your custom on-prem data lake.
Yeah.
Good luck. I mean, fine, if you want to compete against Cylake, doing it just for yourself,
Yeah.
We're going to spend $100 million doing it.
Yes.
You'll probably have to spend $100 million doing it.
Yeah.
You'll do it for yourself. We'll do it for enough customers to justify the $100 million investment.
Hello, and welcome to Inside Cybersecurity with Cylake. My name is René Bonvanie, and I'm responsible for marketing at Cylake. Today, I'm back with Nir Zuk, founder and CEO of Cylake, to talk about a very interesting, but also contentious topic, namely that of AI, and specifically the use of AI in cybersecurity, and some of the conversations that are happening in the market right now around the use of AI, generative AI included. And we have a point of view there that I want to discuss with Nir. Now, before I do that, one of the things that we firmly believe in is that great AI stands on and is dependent on great data. All right, so let's talk about data first, right? And then we'll dive into the specific issues that we see and the answers we're going to have about being an AI native platform. Now, we've heard, right, that the cloud is a great place to store your data, right? And we've seen companies that were either in the cloud storage business to begin with, like Google and Microsoft and Amazon offer that, but also companies that are in the data management space, like Databricks and Snowflake and others. What do you think of that? Right? Because they say, oh, you can store all your security data in the cloud and it will just work. Right? How do you think of that?
So I think you could store all the security data in the cloud if you had a way to get all the security data into the cloud. And then if you're willing to pay the money that it takes, and okay, so you store the data. What's now?
Yeah.
What are you going to do with that data?
Yeah.
Someone needs to operate on the data. So now you need to go to all your cybersecurity vendors and convince them to use the data that you stored in the cloud, or you need to build it all yourself. So I know a lot of organizations out there believe they can build this SOC functionality themselves, but then what about data security? What about DLP? What about AI security? What about cloud security, SaaS security, API security, IoT security, OT security? Okay, I need to breathe.
Yes, please.
And so on. Who's going to run those on top of your data that you stored
Yeah.
in the super expensive cloud storage, assuming you could even get the data?
Yes.
So let's talk about what data you need.
Yeah.
You need data from the browser. How are you going to get the data from inside the browser? Like everything that happens inside the browser. You need data from the endpoint, system codes. You need data from the endpoint, DLP data, so all your files and so on. You need data from your cloud workloads. You need data from your cloud logs. You need data from your SaaS APIs. You need data from your general APIs, API gateways, and so on. You need data from your network. You need data from your identity and access management systems. You need data from your applications. You need data from your code if you're doing source code security. You need to get data from your CI/CD pipelines. How are you going to get all that data?
Yeah.
And how are you going to push all of that data into the cloud storage? And then on top of that, we'll probably talk later in this podcast about how it's not just storing the data, it's also processing the data during ingestion.
Yeah.
And those services that you talked about don't offer an ingestion pipeline. So you need to build your own ingestion pipeline using something like Kafka, which is very difficult. And then you actually have to process the data there. Now, unless you're going to build the entire cybersecurity stack that I mentioned before, you now need to go to all those different vendors that I talked about and convince them to use your ingestion pipeline against whatever it is that they do during ingestion, which is usually attack detection.
Yeah.
I just don't see that happening.
No. So you're making 2 points, right, in one, which is you need to be able to get to all the data, right, at the source, not some derivative, not some API.
Not go to your EDR vendor and all the data that they managed to store in their data lake after they got rid of 90% of the ingested data. You need the raw data.
Yes, you need raw data. Because then you can effectively build a single pipeline. So tell us a bit more about what you mean by pipeline. Right? What does that look like? And what kinds of things can you do on a pipeline?
So First, you want cybersecurity to be as real-time as possible. So ingestion is when you ingest the data, you have a pipeline where you do different things. We can talk about what you can do
Mhm.
there. Eventually, you decide to get rid of some of that data and store the rest long-term. You don't want to operate on the long-term data for all your real-time requirements because it takes a while until the data gets stored, and then reading it again is slow and so on. So you want to do it during ingestion.
Mm.
That's when the real-time things happen. Uh, and that's when you have access to the entire data set, right? You get rid of a lot of it when you store it. So probably the most obvious thing that you want to do during ingestion in your ingestion pipeline is your attack detection, right? Real time, all data. That's when you want to detect your attacks. And that's relevant for all of cybersecurity, not just for the SOC that wants to detect attacks. But if you're an AI security module and you want to detect AI related attacks, you want to do it there.
Mhm.
If you are a DLP module or a data security module, you want to do it there. If you are a CASB, a SaaS security, you want to do it there, and so on.
Yeah.
So the pipeline is where those different cybersecurity modules, different cybersecurity functions do their real-time attack detection, as well as real-time policy enforcement sometimes happens there. I mean,
Mm.
it's not that you enforce it there, but you see a policy violation there, and then you go and remediate it immediately. You don't want to wait until it gets stored because not all of it will get stored and it takes a while, and then figure out if there is a policy violation and go and
Yeah.
do that. So that's the pipeline.
Yeah. Do you have an example of if you have more than one pipeline, what things you miss or what things you couldn't see?
I have many
Yeah.
examples.
Give us a few. Yeah.
So if you are an IoT or OT security company, your ingestion pipeline usually includes network logs, or if you have your own network probe, logs coming or data coming out of the network probe. Sometimes, rarely, you can sit on the IoT itself or some API the IoT or the OT device provides and read something from there, but usually it's from the network, which is great if you want to look for command and control
Mhm.
connections and other misuse of network, which is a good way to see if the device is home.
Yep.
You completely miss what's going on the operator's machine. So if there is a Windows machine or a Linux machine that controls the infrastructure, for example, if it's a CT or an MRI, it would be the machine that the tech is using to run the scan. If
Yep.
it's an OT environment, it's the machine that
Mm.
controls the industrial machine that's building your products and so on. You're going to miss all of that. It's not in your ingestion pipeline. The data from those endpoints is with your endpoint security vendor.
Yep.
And if it's a browser-based application, the data is also with your browser
Yep.
vendor,
Yep.
your secure browser vendor.
Yep.
There's no place where you see all those three together in the same pipeline coming in at the same time
Yep.
so that you can do your IoT and OT security based on all that data. The same is true for pretty much everything in cybersecurity.
Yep.
You never see all the data that you need in a single pipeline in order to perform attack detection.
Yep. Now, if the cloud isn't the right place to store it, right, or to build the single data lake, and building a single pipeline, right, is a hard thing as well. Um, why shouldn't you build it yourself? Right? If the cloud isn't the right place and nobody's doing it anyway, why wouldn't you build it yourself?
Again, it's
And
not that the cloud is the wrong place.
okay.
It's an expensive place.
Yeah.
And for both, whether you do it yourself or someone is doing it
Mhm.
in the cloud, the challenge is not doing it.
Right.
The challenge is what do you do with the data?
Yeah.
Well, if you do it yourself, you'll need to operate it.
Yep.
So if you use something like Elastic
Mhm.
or some other storage, someone needs to operate it
Yeah.
on-prem if you do it on-prem. But that's not the issue. The issue is where do you get the data?
Mhm. Yep.
Okay. And yeah, I hear some customers saying, oh, we're going to get it from the EDR vendor.
Yeah.
Great. You're going to get it from the EDR vendor during ingestion?
Yeah.
No,
No.
you're going to
No.
get it when it's stored. That's much less data, and you cannot do any real-time processing there. And then what about your browser
Yep.
vendor?
Yep.
If you have a secure browser vendor, you need to get it from them. You need to get it from your identity and access management vendor. You need to get it from your CASB vendor. They don't provide that. You need
No.
to get it from your cloud security vendors. You need to get it from your CI/CD security vendors. You need to get it from your source code security vendors. You need to get it from all the different vendors that you use in order to get the right data
Yep.
into there. So It doesn't matter if you run in the cloud or you're trying to do it on premise. On premise, you'll probably fail because you're going to try to do it yourself. And
Mm.
everybody that's been trying for the last 10 years to get Elk,
Yep.
Elastic, Logstash, and Kibana
Yep.
to work knows very well that on-prem fails. And but even if you succeed on-prem or you're willing to pay the cloud cost of using something like Databricks or Snowflake, you will not get the data.
Mm.
Now, let's say you got the data. What's then?
Yeah.
What I hear some customers say, we're going to use agentic AI. What are you going to do? You're going to
Yeah.
get an agent and prompt it, fix my cybersecurity challenges, and then
Yeah.
it's going to go out and fix your cybersecurity challenges?
Yeah.
Who's going to do the detection for you?
Yep.
LLMs are not good at detection. Even if they were, someone needs to tell them how to do it, but they're not.
Yeah.
Machine learning is good. Who's going to build your machine learning? Okay, let's say you built a machine learning pipeline. That's not too difficult to do. Who's going to write the thousands of machine learning models that you need?
Yeah.
And then policy and all that stuff. You'll have to do what Cylake is doing, which is to rebuild the entire cybersecurity stack on top of your custom data pipeline and your custom on-prem data lake.
Yeah.
Good luck. I mean, fine, if you want to compete against Cylake, doing it just for yourself.
Yeah.
We're going to spend $100 million doing it.
Yes.
You'll probably have to spend $100 million doing it.
Yeah.
You'll do it for yourself. We'll do it for enough customers to justify the $100 million investment.
Exactly. Yeah.
So I just don't understand the logic of customers trying to do it themselves. I mean, I understand the logic. They are very disappointed
Yes.
with existing solutions like Splunk, which is not only a 25-year-old product, it also went to die at Cisco, or McAfee, which is not only a 35-year-old product, it went to die somewhere else. I don't even remember the name of it.
Trellix.
Trellix.
What?
Trellix is not something you put outside your...
That's a trellis.
Oh, that's a trellis.
Close enough.
And it's probably not even good for that. And so I understand frustration in the market from these solutions.
Of course, yeah.
But the solution is not to try to do it yourself and add to your current SIM logs some EDR data that was collected 4 days ago, and then try to run some agents on it that are going to fix all your problems.
And yet there are dozens of SOC agents now, right, being touted as figuring these things out and understanding and learning.
So, yes, I heard from very few customers that they think that their SOC agents can find attacks for them.
Yeah.
That's very easy to shut down. I'm sure we'll talk about it soon.
Yep.
But theoretically, you can use agents to explain something bad that happened and you already figured out. You can probably use agents to replace playbooks in your SOAR.
Yep.
I mean, okay, these are two use cases.
Okay. We have now landed in the AI, on the AI topic, right? And let's focus on, first and foremost, what is AI in general doing to cybersecurity? From the attacker side, let's start there, right? So what is AI doing for attackers? Does it help them be more successful?
So generative AI has completely changed the landscape when it comes to attacks.
Mm-hmm.
Completely. For one main reason. A lot of the cybersecurity market is focused on trying to keep the adversaries out of your organization. That's completely out right now. And the reason is that the assumption around trying to keep the adversaries out of your organization is that 99% attack detection rate is good enough.
Yeah.
And it was good enough when developing a new attack was very, very expensive. Because statistically, if you're going to succeed 1 in 100, if you want to be successful, you probably need to develop 300, 400, 500 different attacks so that statistically one of them will go through because, never mind, you want to be in the right place in the curve bell. And developing hundreds of attacks is super expensive. It's only nation states.
Yeah. Criminal organizations.
Criminal organizations, maybe.
Maybe.
What generative AI did is it significantly reduced the cost of developing a new attack. You can prompt for a new malware.
Yeah.
You have to work a little bit to make it work. You can prompt for a new command and control infrastructure and protocol. We're now seeing more and more AI being good at finding vulnerabilities and even exploiting the vulnerabilities. So now the cost of developing a new attack is so cheap that developing hundreds of attacks in order to bypass a 99% detection rate. Not that there are any, but let's say
Yep.
system makes that reduced cost, which is in the, call it $100 for developing this number of attacks, is making those perimeter-based or endpoint-based, let's keep the adversaries out, solutions useless.
Yeah.
Okay, I was at Palo Alto Networks for so many years, and in the last few years, I told that to customers, and there are people at Palo Alto Networks that are really upset with me.
Yeah.
Don't tell them that our firewalls cannot stop these attacks. I'm like,
Yeah.
sorry, that's reality. You have to do
Yeah.
something else. I mean, luckily, Palo Alto Networks has solutions around that. But so what Gen AI has done is it forces us as defenders to shift our mindset from let's keep the adversaries out to let's assume that the adversaries are in. Now let's go and find them and stop them as quickly as possible.
Yeah. Now, you mentioned vulnerabilities, and I want to put a fine point on that because much is said about mythos and how it's going to change, right, the cybersecurity landscape forever. You don't agree with that, but you also have a perspective on the impact of doing vulnerability management right. So give us a bit of an idea about how you look at that, but also how you would argue that it's a small problem, not the big problem that needs to be solved.
Of course. So Anthropic with Mythos claim two things, which are, by the way, opposite to each other. The first thing they claimed is the world is screwed because we have this super powerful model that's going to detect all the vulnerabilities, and those vulnerabilities will be exploited by adversaries. And so that's the one thing they claimed, which, by the way, I don't think it's true. Yes, it's detecting vulnerabilities, not much better than other models and not much better than humans can.
Okay.
But okay, it's detecting vulnerabilities. And then the second claim that they make is there are going to be no more vulnerabilities in the world because we're going to fix all of them. So you don't need cybersecurity anymore.
Yeah.
And the point I would like to make about that is that even if you found and fixed all the vulnerabilities in the world, vulnerabilities are being used in less than 5% of attacks. And in less than 5% of successful data breaches out there.
Yeah.
Most data breaches, most attacks rely on social engineering.
Yeah.
So phishing, dropping a USB key in the parking lot, writing on it HR confidential, and hoping that one of the employees will put it in, and because they want to see how much their peers are making, and that's going to start an attack. And other social engineering, getting your co-conspirator hired by a company.
Yep.
That's also a type of social engineering.
Absolutely.
Right?
Yeah.
Get someone into the company. So a lot of data breaches are based on that. And then we're seeing more and more data breaches starting with SolarWinds that are based on attack chain.
The supply chain. Yeah, the supply chain. Yeah.
Where if you were to attack an organization, you attack one of the suppliers of the organization, and then the next software update gets you in, or the next product that they buy gets you in. It has nothing to do with vulnerabilities.
No.
So even if you fixed all the vulnerabilities in the world, which I don't think you can, then you haven't fixed the problem. Even those 5% of attacks or less that are today exploiting vulnerabilities, they will just switch to one of the other methods. It's not like you're even going to reduce the number of attacks out there by 5%.
Yeah. I think that is an incredible point because, so many times we hear, oh, the cybersecurity industry is going to be disrupted by AI because somehow it can play the adversary or it can play the defender. But then when you look under the cover, it is a tiny sliver, right, of the cyber. And we see this now in SOC operations, right, where folks say, well, I can make your SIEM run better, right? It's not good. Everybody says the SIEM is not good, but I can make it run better.
Of course,
right?
it's a agentic AI. Yeah, you just prompt it, fix my cybersecurity problems, and it does.
Really?
Yeah.
No. So
no, it is useful technology in some cases.
Yes.
Tell it. So let's put this off the table.
Yeah.
To start with.
Yeah.
Gen AI is not good at detecting bad things.
Let's start there.
Okay. What's good at detecting bad things is machine learning. If you want to use AI, you need machine learning, not generative AI.
Yes.
The reason Gen AI is not good at detecting bad things is because Gen AI has very limited windows, the context window that it operates in.
Yeah.
So even if your context window is, call it 2 million tokens, which is a big context
Yep.
window. 2 million tokens is about, call it 20,000 security events.
Yeah.
Attacks span more than 20,000
Oh,
events.
yeah.
Not. I mean, if you know in advance which events are part of an
Well,
attack,
wouldn't that be nice?
and you give it to an LLM, then LLM tell you, yeah, there is an attack.
Yeah, but that's not how it works.
But that's how it works. The way it works is you need to collect a lot of events
Yep.
that you don't know if they're good or bad.
Mm.
And then something needs to look into those events and tell you whether they're good or bad.
Yeah.
In LLM, you're limited to, again, call it about 20,000, maybe 50,000 events in a context window, which means you have a rolling window of 50,000.
Yeah.
Now, 50,000 events, a typical organization collects between 1 million and 100 million events per second.
Yeah. Yep.
How are you going to choose the right 500 events?
There's no way.
Or, sorry, 20,000 events.
Whatever the number. Yeah.
Well, and
Yep.
even if you did, you need to run that prompt multiple times per second. I mean, you can do the math. We're not going to do it here on this podcast, but if you really, if somehow you can take millions of events per second,
Yeah.
pinpoint the few hundreds that you need to pass
Yeah.
to the LLM, which you can't,
Yes.
because if you know how to pinpoint them, then you probably know what the attack is,
Yeah.
but you don't. And you actually pass it to the LLM on a rolling window basis, and you're only looking for attacks that are as long as the window can include, which is, call it 3 minutes in the case of 2 million events. If you're okay, then all you have to do is to spend about $1 billion a year on tokens,
Only $1 billion.
and
Yeah.
you'll be fine.
Right.
So LLMs are not going to detect attacks,
Yep.
period.
Yeah.
Okay? They might be good at other things in the SOC and outside the SOC if you have the right data. And we can talk about that.
Yeah. Yeah. So one thing we'll do is on the Substack that we will release in conjunction with this podcast, we'll do the calculation. Because I think folks don't really grasp, right, how cybersecurity is a terrible use case for LLMs, right? And the way that it works.
Yeah, for something that you pay by the token,
Yeah.
and you get millions of tokens per second.
Yeah. No, it's not the right use case for LLMs.
You get hundreds of millions of tokens per second.
That is correct. Now, and yet we're building Cylake, right? So how do we do that, right? What is the alternative than trying to do this? Right? You said there's lots of work we can do in the on the ingestion pipeline using machine learning.
Yes.
So where do you want to apply generative AI, right, on our data lake, and give us some examples of where LLMs are really good, right, from a cybersecurity perspective.
So on the machine learning side, machine learning is really good at looking at millions of events per second across many days and weeks if you have the right underlying data lake in conjunction with the ingestion pipeline. So machine learning is the right tool for the task of detecting bad things, especially behavioral-based bad things in very large amount of data. Now let's talk about the use of LLM in cybersecurity. Let's start with the SOC, because that's where most organizations that are trying to apply generative AI LLMs are going to start. So LLM, and the first use case I've heard about LLM that probably makes sense, that customers are trying to do, is to explain bad things. So you detected the attack, either using one of your existing cybersecurity solutions, maybe using LLM, maybe using a correlation rule in your SIEM or whatever. You detected an attack. Now you need to explain what happened. Less to yourself as a SOC analyst, because you know how to understand what happened, but to higher levels, all the way to the board.
Yes.
So either you sit down and write for a few hours the incident, or you give an LLM the incident and have the LLM write it for you. We know that LLMs are really good at writing stories.
Oh, absolutely. Yeah. That's what they were developed for.
That's a good use case. Okay. Is that going to save the world?
No.
You being able to write an explanation to your board in 1 minute versus a few hours? Probably not going to save the world. It's going to make your life a little bit easier. Also, if you look at the process of from the time I detected something bad until I'm in a position to explain what happened, I need to understand what happened. I need to figure out what happened. It's a very labor-intensive process. It requires you to go to many different systems and piece out the timeline of what happened. Turns out you can do it automatically. You can create that timeline automatically but not using LLMs.
No.
LLMs are
No.
not good at that. You need to do it during ingestion, and you do it using machine learning and other techniques. To do that, you need to be really good at the data you collect.
Yes.
So, for example, you need to be able to connect some activity that happened with your Office 365 or G Suite.
Yep.
If you prefer to use a product from a company that doesn't get breached every other day. And something that happened on the endpoint, and then something that happened in your email, and maybe something that ended up in the cloud.
Yep.
So you get those separate events from different areas of your infrastructure, and then the question is, how do you create a timeline?
And those are very long timelines.
Those are very long timelines. SOC analysts are good at it. It just it takes them sometimes hours and days to do that. If you want to do it automatically, you would have to collect all the relevant data to do that. So collect the data from all these different areas of the infrastructure. And still, even then, it's very difficult to connect the activities in those different areas of the infrastructure unless you do it through files and data. So you see a file in Office 365, you see it going to the firewall, now it's on the endpoint, someone is modifying it on the endpoint, maybe copying some of it and pasting into another file, and then they're emailing that file, and then the chain continues. If you can track the data, including the copy and paste, really, really well, you'll be able to create these huge timelines, which then you provide to the LLM, and the LLM can explain to you what happened. Organizations are not in a position to do that. Nobody does that very well today.
Right.
So you still need the human to work for a few hours to figure out what happened before the LLM can save you a few hours writing up what happened.
Okay.
We at Cylake, during the ingestion pipeline, we create those timelines. So we can then feed them into an LLM that will explain what happened. And you save the few hours on both ends, investigating what happened. Okay, so that's one use case for LLM.
Okay.
Explaining what happened. If you want to do it really well, you need to know what happened. You can either spend 4 hours of a human knowing what happened, or you can use machine learning to understand what happened. Okay, so that's one area. The other area where LLMs can be very good at is with your automation, with your SOAR, security orchestration, automation and response, or what we call RPA because we're older, robotic process automation. So today, most SOARs, the way they work is you need to create a playbook in advance for each type of alert.
That's completely predetermined.
It's predetermined. If you get this alert, this is the playbook. If you get this alert, this is the playbook.
Right.
Okay. Go figure out if there's a URL involved, and if it is, block that URL. And, that's a type of a playbook that you see. Turns out that in some cases, LLMs can, on the fly, given the incident, suggest what the response should be. So it doesn't have to be predetermined in a playbook, but it can be much more dynamic and save you a lot of time preparing those playbooks. To do that, first you need to have that timeline that I talked about before, because you need to know the entire picture. You need to know exactly where in that timeline you need to go and stop something. And second, you also need to train the LLM to do that. That's very, very difficult to do. Here at Cylake, we do that, but I'm seeing customers try to do it themselves. Meaning they're trying to take a few events from the scene, which are not connected to each other. You don't know that they're connected to each other, like 2, 3, 4 events, and ask an LLM to tell them what to do about it. I just don't see that happening.
No,
but fine.
no.
Okay.
Any ideas about how AI changes the way that we interact with a security system? We're used to CLI, to UI. That's not how AI works. Right?
I think that every good security solution needs to support CLI access and traditional GUI access, especially if it has users that are reluctant to adopt new technologies. But here at Cylake, we're doing what I believe everybody should do, which is, if you're going to build a new system right now, the interaction with it should be LLM-based.
Okay. Meaning
generative AI-based, chatbot-based. The analyst or the user that configures the policy, or the user that gets or configures the visibility, the dashboards, and so on, all of these, they need to interact with the system with the chatbots.
Right.
Not using...
So prompting, voice.
Exactly. Not through traditional rule bases and not through traditional, let's go to 10 different screens and find the checkbox that... Just tell the system, turn this feature on,
Yeah.
instead of looking
Yeah.
for it through 10 different
Exactly.
levels of screens.
Yeah.
So yeah, Gen AI can be useful for that. And then Gen AI can also be useful outside of the security operations center. So far, we talked about SOC.
Yep.
We talked about,
Yes.
well, the interface is not SOC. The Gen AI interface is, I think, true for all of cybersecurity. But detecting attacks in the SOC, Gen AI irrelevant for that. But we talked about
Yep.
it in the context of the SOC. Explaining what happened, that's the SOC. And coming up with a playbook, a response, that's also in the SOC. Generative AI is also useful outside of the SOC. It is useful when you want to classify data, when you need to classify data. So things that come to mind, DLP, data
Yes.
loss prevention.
Yep.
I wouldn't use LLMs to classify the documents because there are much cheaper methods to do that, like supervised machine learning. So to tell that a document is source code or a document is financial something or healthcare
It's PII
and so
data.
on, PII and so on. And you don't need an LLM for that. You can. It's just that the token cost will be astronomical. You shouldn't use an LLM for that. But then understanding the context of a document inside an organization, which today is a very tough problem. So classic example is you're a public company, you're about to release your financial quarterly.
I see where this is going.
Yes, René, the time that you put it on a staging publicly available web server 30 minutes before the announcement. But yeah, it's a use case, right? So until 4:05 or 4:10 Eastern time, the day you announce your earnings, that's the most sensitive data. And then after that, it becomes the least sensitive data. Everybody's going to email it to their friends, right? Who's going to tell DLP that happened? Well, it turns out that Gen AI is pretty good at understanding context within the organization and understand that at 4:05 or 4:10, there's going to be an earning release and it's time to change the classification of the data or the policy around the data. The classification happens before. So Gen AI is good for that. Can you use that? Yes. We've tried it in the past. It's just way too expensive to do it in the cloud. And then customers were telling me, you're going to send all my documents that I send you for DLP to a Gen AI provider that is known for ripping off the data and using it for training their next model. Not going to happen. So part of the solution is do it on premises. Other use cases that are related to using Gen AI for classifying data, phishing. But then you have to take all your emails and give them to an LLM. It's expensive. And also assume that your Gen AI vendor or the Gen AI vendor that your cybersecurity vendor is using is going to use all your emails now to train their next gen model. So there are some use cases for LLM that are expensive. They have a lot of data sovereignty challenges for everyone, not just for those that have real data sovereignty issues. But in those cases, LLMs are useful.
So one of the things that you just mentioned, right? Can I trust this third party with my most precious data? You sometimes said that suffers from the Harry Potter syndrome, right? You train your models on content that isn't yours, and then you go off and build something. Oh, yeah, that too. Right?
I think Anthropic had it. They agreed to pay $2 billion on some copyright lawsuit. And they don't even feel it. They go and raise that money immediately. Yeah, they are learning from data they're not supposed to learn.
So when you're building Cylake, how do you then show to your potential customers how you're not suffering from that, right? And how you are not using their data and how you are truly not a black box when it comes to AI?
I don't have their data.
You don't have their data.
Right? It's all running on premise.
Okay.
The LLMs are on premise on on-prem hardware that we provide. It's hardware and software that comes in an appliance. The GPUs are there, the CPUs are there, the memory is there, the storage is there. I don't have access to the data. I cannot learn from the data even if I wanted to. It's in their walled garden and nobody can access it.
Now, that is a significant difference, right, with anything that is out there in the world, right?
Yeah.
Not something you can just build yourself, not something that you can approach by putting it in some, private cloud instance of Microsoft or anybody else. That has to come from a specialized vendor.
You can try to build it yourself. So, let's talk about the use cases we talked about before. Let's say that what you want to do is you want to use LLMs for explaining what happened. Okay, so Somehow you're a super capable cybersecurity team that has a lot of data scientists,
Yep.
cybersecurity experts, has software engineers, and you can build your own ingestion pipeline, use machine learning to create the timelines.
Yep.
And now you have the timeline that you want to provide the LLM and the LLM to explain.
Yeah.
Someone needs to teach the LLM to do that.
Mm.
If you test it on publicly available LLMs, it's not going to work very well.
No.
How do you teach the LLM to do that? Where you need to retrain the LLM or post-train the LLM. You need to give it a few hundreds or a few thousands of examples of, here is a timeline, here is the report. Here is a timeline, here is the report. And if you do it the right way with the right people that know how to do it, then eventually you can teach an LLM how to take a timeline and generate a report from it.
Yep. Yep.
Okay, so go and hire
Yep.
20, 30 content writers that are going to develop these.
Yes.
I'm not saying it cannot be done. I'm just saying you're going to have to spend the same amount of money that Cylake is spending on it,
Just for
which is
yourself.
tens of millions of dollars just for that. But you're going to do it just for yourself. You will not recoup it. Whereas at Cylake, we're doing it for the entire world.
Yep.
And we will recoup those tens of millions of dollars that we're spending on it.
Yep.
And we can find the people.
Yes, we can find the people.
Because we pay Silicon Valley money and we give Silicon Valley stock options, whereas most of the organizations out there will have significant challenges attracting the machine learning talent, the data science talent, the data engineering talent, and the LLM talent that knows how to do those. And the cybersecurity, by the way. You need people that know how to attack in order to build these defenses. At least that's our experience from past lives.
Yep.
It's very difficult to attract those into a non-Silicon Valley or one of the other major cybersecurity hubs in the world like Tel Aviv.
Yeah. Awesome. So I think we've come to the end of this conversation. What is very clear is that you're not negative on AI, but you're negative on the way people think about the usability of AI within the context of cyber. LLMs have a great use, but in specific use cases. They're certainly not going to end the significance of good cybersecurity. Machine learning, very important on ingestion. And in general, this is not a DIY exercise. It's not going to. And by the way, if you try to apply AI to existing cybersecurity products like a SIM or EDRs and so forth, it's not going to go very well.
Because you don't have the data.
You don't have the.
Adding your EDR data to the SIM is not going to do anything when it comes to
very good
generative AI.
Okay. Thank you so much, Nir, and thank you, listeners, for being part of this really good podcast. See you next time on the next episode of Inside Cybersecurity with Cylake.